Hello everybody, how you all doing? So in today's video we're going to cover what are methods and what recursion is in Java. Also, one thing I want to mention, you might have noticed that last week's video, or actually the past few videos, have been a little longer. I tried to change the style up a little bit where I explain pretty much every part of the code so that it makes sense to everyone, and since Java is inherently more complicated, it takes a little bit longer to explain everything and how everything works in Java. So yeah, also I've been recently getting a lot of requests for so I could cover like different languages and possibly even different frameworks. So just keep sending those so I know what I will be able to do on this channel, because that's pretty much all I'm doing right now. I'm just explaining code. Anyways, getting sidetracked. So, first we're going to cover what the methods are. So what are methods? So methods are essentially a block of code that runs when it's called. So one of the advantages of this is you'll be able to pretty much not repeat yourself, which will enable us to do that, because the last thing you want to do in your code is to just keep repeating yourself and make your code a lot more complicated than it should be. So a good programming practice is to just write the code and not be able to repeat yourself, because it doesn't seem like much since we're writing really simple code in the beginning. So you do not need a really powerful PC. Like mine isn't powerful at all. So I'm still able to record videos, make videos, and stream on this, but that's because the CPU is pretty good, but everything else is crap. So if you're planning on making a development machine, just focus on getting a good CPU. Anyway, I'm getting sidetracked again. So as I mentioned, methods are blocks of code that can be called to do certain functions. We can also pass data as parameters into a method, but I'm going to cover parameters real soon. So pretty much we can define our code once using a method, and we do not have to rewrite that section of code or that function ever again. So let me show you a quick example of how you can define a void. In Java it works a little bit differently. What you do is you type in static void, and let's call it my void. And we're going to not define any parameters as of now because it's not important. So we've now successfully defined ourselves a void, or a method essentially, but I'm going to call it my void. We can also call it my method if you want to, but I'm going to call it my void because it's simple. So that's pretty much our method defined, but it's not going to do anything. It doesn't have anything in it. So what we can do, we can make it so it prints out some text. If you remember in some of my previous videos, we can actually make it print out text. So what we do is we type in system.out.print line, and we can close this out, add these double quotes, and say this text, type text is inside my void. There we go, and 3 dots. Why not? So that's pretty much it. So you would assume that by writing this, it will write something out. Well, let me show you what it does. It's actually not gonna do anything. See, it's not gonna do anything. It will compile and everything, but it's not gonna do anything at all. Also, let me align this because I really hate how it automatically tries to align, but it doesn't look good. So you want to print it out. So what you do is you move back into your main function here, into the main section of the code, which is public static void main with this parameter here. So you move back into the main section of the code and you just call the function my void. So what you type in is my void, and these regular brackets, the open bracket, closed bracket, and then the semicolon. So now if we decide to compile it, it compiles just fine. But if I decide to run it now, as you can see, it prints out and it says this text is inside my void. So the thing is that that's what we wanted to do. We pretty much wanted to like replace one line of code with one line of code, which we did, but it's not really ideal and it doesn't make really much sense. So the reason why I'm covering methods now is if we want to make complex applications like a calculator or something, we want to create methods to assist us in writing all these bits of code. We can use voids or methods to create menus with this, so we don't have to define them in our main function. We can do various kinds of things, so we pretty much don't want to repeat ourselves. So if there is a section of code where you have to repeat yourself, it's easier to just write out a void and call the void. And here's a really cool thing: we can actually call the void multiple times. So it's pretty much as if I wrote down both of these lines. So let me just compile this and run it. As you can see, it will print out the text 2 times instead of once. Even though we've written out once, we can call the function twice. But I'm getting sidetracked again. So we're going to leave this here because I want to work with this my void function. We can also make it so that we have like multiple lines of code inside of this one method. For example, I want to print out numbers from, I don't know, 1 to 4, for example. For that, I'm going to use a for loop, which is another optimization method, and it just makes a lot more sense to use something like this for this, instead of like having to, you know, write it out manually, and it's a pain in the butt. So I'm going to do that int I equals 1, and we do if I is less or equal to 4, and then we do I plus plus. You don't have to separate them with spaces, but I like to do it so it's easier to read for you guys. And what I'm gonna do is I'm gonna type in the system.out.println, and we're going to print out just the number. So pretty much what we've done here, if you remember from my last week's video where I covered loops, we're printing out numbers from 1 to 4, so it goes in. It says it's 1. Is 1 lower than 4? Yes, it is. Print out the number. Increase. Is 2 lower or equal to 4? It is. Print it out. Increase. Is 3 lower or equal to 4? It is. Print it out. Continue. Is 4 lower or equal to 4? It is. Print it out. Increase. Is 5 lower or equal to 4? It's not. Do not increase and exit. This is just a quick summary of what it does. So if I decide to compile this now, remember we still in our main function have just this one line of code. And that's the beauty of it. We can literally have 4 lines of code here and be called once or multiple times. So let's just compile this and run it. As you can see, it does what I asked it to do. I asked it to write out a text and print out the numbers. One beauty of it is we can actually let it do it twice, or maybe even 3 times. If you wanted to do this manually, what you would do is you would have to copy and paste it about 3 times, resulting in you having 12 lines of code in the main function itself. So we would be not having 3 lines of code, but 12. And that's not what you want. We want to minimize the amount of lines. So if I run this, it will actually run 3 times. It won't just run once, it will run 3 times. See? Once, twice, the 3rd time. That's the beauty of using methods. You can define sets of code that have to be repeated without having to repeat yourself with a lot of lines being potentially wasted on good code. So that's just an example I wanted to cover. So we've got that covered. So what I'm gonna do is I'm gonna copy this and I'm gonna comment this out so you guys can actually uncomment certain parts or comment something out. Just realized I goofed up that. Good. So I've just commented it out, but it's okay. I'm just gonna, you know, place it back in so we can make changes. So I'm gonna get rid of pretty much almost all of this because I want to show you something really cool. So we've got that, we've got all the things. So one important thing that I've mentioned before is actually, let me actually get rid of this text right here because we're not gonna need it at all. So one like really cool thing about, let me actually copy this set of text as well, like this set of code. I'm gonna comment it out so you guys know that it belongs to that. I'm gonna paste it in again. So here we go. So you remember I mentioned something, a little thing called parameters in Java, or with methods in general. So one really cool thing is that we can actually pass data from our main section of code into our method. Let's say we want to make a method that greets, like, you know, people. It's actually really easy to do. What we have to do, however, is we have to define the parameter itself. The way you do that is you look at our static void, my void thing right here, the blue highlighted one. And what we're going to do is here we're going to write our parameter in these highlighted brackets. So what we're doing here is we wanna, like, you know, make a parameter. Let's make a string parameter because strings are really easy to show as an example. And we wanna call it name, for example. So we have a string variable called name. And what we want to do is say, I don't know, hi. Actually, hi. There. We do a space. We add the name, and that's it. So what we've done here is we've pretty much created a void, or actually a method that will have, you know, what it will do is it will actually take anything we write into these brackets with double quotes and set it as the name of variable. The reason why I used the name variable here and here is here we define it as a specific variable for our method, which is what we want, obviously. So what we do now is we just type in whatever name we want. Let's say Jane, why not? If I can actually, no, let's do John. Let's do John, why not? Let's do John. John is a cool guy. And we're going to compile this and run it. So watch what happens now. It will say, hi there, John. Remember, we did not define it here in this section of code at all. We did not do anything here. You cannot see anything related to John. It's over here. And that's the beauty of parameters. You can pass multiple types of data into certain functions to do really certain or specific things. So what we can do is, like, really cool. We got ourselves a name printed out on the screen. But we can also do one more thing. I'm going to one-up myself here. I'm going to comment these out once again so you guys can actually, you know, like, follow along at home or something. I'm going to comment, I'm going to actually, like, add this one, paste this in because it makes it easier to be reused. I'm going to copy this and I'm going to comment it out again. So I'm going to just leave it here right now. So pretty much we did not change the function as of now, but let's say we wanted to say, like, also that he's a certain age, for example. Well, we can actually define multiple parameters. To do that, remember how I said you can define a parameter here? We can actually define multiple. So I'm going to define another parameter. It will be a full number variable. So we use an integer to do that. And let's say age. So it's a variable, full number variable. It's a full number variable called age. And remember how I called the name variable here in this section of code? We do pretty much the same thing. But I'm going to add a few things, you know, to make it look more professional. So what you do here is say, and his age is, and let me just actually separate this, and here we're going to just add the age variable. It just barely fits in, okay. We can actually like size this out a little more. No, we cannot. Okay. So pretty much what we've got going here is we have a method that has 2 parameters now instead of 1, and it will pretty much do the same thing as it did here with hi there, my name is John, but it's going to print out also the age we write in that method when we call it. So we now have 2 parameters instead of 1, and this is actually really important to remember that if you are adding multiple parameters, you have to separate them with a comma. So what I've done here is I'm going to give him an age, for example 24. Let's say my numlock was turned off. Cool. So let's say he's 24. So what I've done here is I've created a function or a method or a void that has 2 parameters. It has the parameter name and the parameter age. The parameter name is a text-based one, hence why when I call the function my void here, I put the name in double quotes because it's a string, it's text. There's nothing to convert here. But then I have a full number variable inside of my method that is called age. And what I'm doing is I'm then add a semicolon because it's a different section. You can see how it highlights it over here in Visual Studio, so you can see the changes in the method that you're working with. See that? It highlights it. It's a separation. So that means it's another parameter that we are going to change. So John is currently the age of 24, which he should be because we are changing the parameter called age. And what we're doing is we're actually like printing out another section of text which says and his age is and then the number. So I'm just gonna compile this and we're going to run it. And as you can see, oh, it actually looks bad because I formatted it badly. So let me just recompile this and rerun it, but it did work. There we go, it looks prettier. So pretty much what we've done here is, again, we have a method with 2 parameters. The parameters get passed through and it gets passed through the text. So it says hi there John. Hi there John, and his age is, oh okay, that's actually fairly badly written. So his name is John, there we go. So his name is John and his age is, okay, there we go. So it's proper grammar now. So here we go. So his name is John and his age is 24. So what we've done, so remember, we do not have any numbers here defined. All we are doing is calling the function name, the parameter name, sorry, terminology. And all the data with the name and the age is defined over here in the main section of code. Well, that's really cool and all, but we can actually do it for multiple people. Let's say we add another person. Let me just copy this because I'm really lazy. Let's add another person. For example, what's a good name? Luke. Let's do Luke. Type Luke. And let's say he's the age of 21. So what I do now is I'm going to compile this and watch what happens. The text will change according to what the parameters are. So look here. First we call the function, so it's going to write out his name is John, because his name is John, and his age is 24, because his age is 24. And I don't have to write another function at all. All I have to do is call the function my void again, but just change the data around. So now we have a dude named Luke. So his name is Luke, and his age is 21, which checks out. His age is in fact 21. And that's pretty much all you have to know about methods. You can call the methods over and over and over again, therefore making it really simple and therefore minimizing the amount of code you need. Now obviously this is a really boring example, but it's a good one because you get to practice this, you get to change things around. So yeah, we got that covered. So that's actually one of the many use cases of methods that I've shown you today. But there's also another use case for this, and that's recursion. So pretty much what we have here is we're going to reuse some of this code, but I'm going to change a few things around. So I'm going to copy this so I have a base. I'm going to comment it out, obviously, because, you know. And I'm going to comment these two boys out, and I'm going to separate them each depending on what we did. So it's actually easier to know which part belongs to which. So let me just, you know, place this block of code back. And let me just yoink. I'm gonna get rid of these two parameters. So we have the basic again one, and we're going to just copy this part, so we're going to use it now. There we go. So pretty much we have now a blank canvas that we're going to use to our advantage now. So what is recursion? Recursion is the action where a function calls itself to, that's pretty much it. We're going to make a function call itself. That's what recursion is. You know, we're calling a function to make it call itself, therefore executing itself again. And it will keep doing it until it reaches a certain point. So what I'm going to do is I'm going to show a simple example of recursion. It should get my point across. So, yeah. So let's do it. So here I'm going to, you know, I'm going to like make a, so what I wanted to do actually, yeah, I know now. So I'm going to actually get rid of this section, and we're going to do something a little bit different. So I have a static void right here, which is good because I'm gonna like, you know, I'm gonna actually, let's call instead of my void my recursion, like my rec, like so, like my rec. If I have to change this, so it like, there we go, so my rec for my recursion. And we'll add some things later on, I just want to have it prepared. So what this function will do is, if the number, so let's say if, actually I have to define the number first. So we're going to use a full number variable called num, you know, it's simple. And if num is anything bigger than, let's say, 0, then what we want to do is we want to make it so that it like returns, so it like, you know, it takes the number num and it adds to it, actually, am I doing this right? Yes, so we pretty much want to do is we want to return the number, and we want to add the result of this function, but it will be reduced by 1. So let's do my rec. So we're calling the function itself now. Add a semicolon, and what we want to do is want to reduce the value. So we type in num and -1. And if anything else happens, just in case it doesn't like equal out, it doesn't look good, does it? So if anything else happens, what I wanted to do is I wanted to return 0. Just as a safety measure, just in case someone types in a number that's lower than 0, like -1 and something. So to show you what this one, to actually explain everything, so we have created a function called myRec, you know, for my recursion. And we have added the parameter num, which is a full number variable. And it will be the sum of all the numbers lower than num. So it pretty much returns the result where it will show you like, you know, it will count down from a number. So it will do, if we type in, I don't know, 10, it will go 10 plus 9 plus 8 plus 7 plus 6 and so on until it reaches 0. At least in this case. Once it reaches 0, it's actually like, you know, going to exit and do nothing at all. But it's not gonna do anything as of now. So we have defined it, but it's gonna do nothing because we did not finish this section. We actually didn't even say yet what number it's going to count down from. To do that, it's very simple. All you have to do is we're going to create a full number variable called result. And we equal it out with myrec, and here we type in the number. Let's say 10. And what we do now is we print it out. So we do system.out.println, and we're going to print out the result. So what we've got going on here now is we're calling this function. We just called myrec, which is for the recursion that we're going to do. And what it's pretty much going to do is, I'm just checking how the time is. Yeah, 26 minutes, good. So pretty much what we're doing is we're checking, is the number that we're going to write out with anything bigger than 0? Which it will be, obviously, because, you know, it's number 10, it's bigger than 0. So it will go in, it will take the number and add to it. Then it will take the number, but it will reduce it. So it will actually take the number, reduce it by 1, so it will make it into a 9. So it will write out 10 plus 9 plus 8, because, you know, these are still bigger than 0, plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. And once it reaches like 0, it should exit and leave us with a, you know, with a blank window. It should leave us with those numbers, which is what we're doing here. We have made a variable called result, and it's going to print. It's going to we're taking our rec function that we've created right here, a recurring function or recursion called myrec, and it's going to do it with the starting number 10. So it's going to print them out with this line of code. So pretty much if I decide to compile this, it will say that we have errors and that it cannot be converted into a int. Huh. Why is that? Oh, I know. We are converting void into an int, so this has to be changed to an int because it's a number, dummy. So again, remember, your data types have to be the same type. You cannot use multiple data types. So now it's going to work. See, now it compiles just fine. And if we run it, it prints out 55. Huh. Okay. Well, it is actually true because the value is 55 actually. But I still don't get why it... Interesting. Yeah, it actually like makes sense because if let me just add the numbers here from the notes I have. Yeah, it actually is 55, so that's pretty much the result, which is what we wanted. So it pretty much calculates the entire sum. So it pretty much, what we're doing here is we're counting factorials. What a factorial is, it's pretty much a number that's written out in a session like 10 plus 9 plus 8 plus 7 plus 6 plus 5. So it's a really easy example. It's an example where you would actually use recursion for this, because it makes a lot of sense to use recursion for this. Because what you want to do is you want to actually make a sort of a calculator, and let's say you want to count, I don't know, for 256, which humanly would take you like a lot of time to do, which it would, because if I decide to run it now, like compile it, and it will take me like ages to count. But for my computer, it just takes only a few seconds to calculate all of this, which is the beauty of writing code like this. You can make recursion functions and it will do the counting for you, which is really easy. Now the formula is easy, but you would be sitting there for ages writing it out painstakingly by hand. So that's one example of recursion. However, we can also halt the recursion. We can make it start at something and stop at a certain point. For this, we're going to use multiple parameters, like I mentioned before. So let me copy this section of code once again, and we're going to comment it out again. And we're going to actually now like legitly paste it in, because we're going to use it, and we're going to do some changes to it. Same thing as for here. I'm going to copy this section of code, and I'm going to I don't know, let's comment it out again, and I might just change the size or the number. So let me just change it to 10 again, so that it, like, you know, doesn't look weird. Let me change this to 10 again. Okay, so pretty much the code is left unchanged right now. But let's say we want to define a starting point and an end point to our code. That's really easy to do as well. We are going to define now two different like variables. Let me see what we got going on here. Yes, I now know what I want to change it to. So I'm going to change the number num to end here. Just give me a sec. Okay, it moved me up. Okay, good. So I've changed it to end now, and I'm going to add another variable, and I'm going to actually add it at the beginning so it looks prettier and it makes sense. So I'm going to create another one called start. And what we want to do is want to check if it's if the end is bigger than start, which it obviously should be. And what we want to do is we want to take the function we did before, but we're going to add here start. So it now has a starting point and an end point. And here we're going to return end just in case anything bad happens, or just in case this function doesn't check out. So pretty much what we have here is it's going to add all the numbers between a certain range. The first number is going to define the start, so the starting point. And the last one, the end one, the end number, is where it's going to end, which is what we want. So now what we have to do is we have to add the starting number. So let's say 10 will be our ending number. So let's say we want to count, I don't know, we want to add up all the numbers with recursion. So we're going to use, in this example, our function, our recursion function. That's a mouthful. And we're going to add all those numbers between 5 to 10. So like, you know, that's like what we want to do. And it's gonna just print out the results. It's gonna add those up for us, and it's going to do it for us. So we're going to compile this, we're going to run it, and that is actually true. So it's like 5 plus 6, which is 11, plus 7, which is 18, plus 8. Does it actually make sense? So can we like, you know, just let's see. Beep tests, that's not it. Yeah, it should say 45, so it's okay. I just wanted to check online if, because I'm not really good at recursion, obviously, but there are some functions I know fairly well from math. Oh, sorry about that. And that's pretty much it. That's all there's to it. That's how you use recursion. It's one of the most used examples, actually. You know, we're adding up all the numbers. In fact, we could like make it like, I don't know, the starting point to be a different number and such. I'm just going to show you what happens if the starting number is anything bigger than the ending number. So actually I'm gonna just then change it back. So let's say the starting number is 11 and the ending number is 10. The thing it should do is it should just return the number 10. I think. Yes, it does, because we've defined it, so it should print out just the ending number. So yeah, don't even bother like trying to troll it. But any other combination with the first number being lower and the second one being higher is okay. So if I run this again, it's going to actually print out the number 45 instead of 10. As you can see, it does. And that's pretty much it. There's not much else to it. That's pretty much methods and recursion covered. Again, it's a bit of a longer video, almost up to another hour, but that's because I'm covering everything in detail, trying to explain everything. So if you like these styles of videos where I just go in depth and show you guys all the things that you can do with these things, just let me know if you like these styles of videos. Personally, I enjoy those because I get to write more code and just, you know, practice everything again, which is good. It's important to keep practicing and writing your code. And that's pretty much methods covered. So I think if I look at my notes here, the next thing we have to do is cover... sorry about that. Is to actually cover object-oriented programming, which is with the use of classes, where we are going to cover like classes, objects, and attributes and stuff like that. There will also be inheritance and polymorphism involved like in the other languages, so just bear that in mind. For now, I will see you guys in a week. In the meantime, I just may pop out a few videos where I do things, like another coding time-lapse video, for example, or just a video about a project I have going on, so that I can keep my YouTube channel alive. So yeah, I hope you guys found this video enjoyable. Leave a like if you enjoyed it. Make sure to share it around if you wanna like teach people how to write code and such. And I'll see you beautiful people in the next video. Make sure to stay safe and get coding.